Well, hi and welcome to my shop today. So, today's focus is going to be on this floppy coil here. This floppy coil, or more properly said, transformer. Let's just take a look at this guy. Now, maybe I should have been much more suspicious of this. We're going to look at this on the schematic in just a moment. But look, the wire coming out of this coil is going right to the grid leak resistor and capacitor. So this is feeding the grid on this tube. Now remember, I picked up a nice clear grid signal with my signal tracer whenever I touch it here, which is the pin of this tube, leaving me to scratch my head over and over. How can you have a strong signal here, but not coming out of the tube? Is there really a strong signal here? Is there really? I'm using my signal tracer to check this. The signal tracer is a radio. Radios can pick up tiny little signals, that's what they do, and make them sound wonderful. Is that what my signal tracer was really doing? That's what I'm wondering. So, we're going to do a very simple test here. No, we're going to look at the schematic first. Let's take a look at the schematic here. Okay, so this is the tube I'm all confounded over. And here's that resistor and capacitor combination here. The grid leak biasing combination, if you like. And now this is a little different. Most radios do not connect the grid of the detector to the earlier stage through a transformer. I'm going to take that back right away. Okay, I'll eat those words. Lots of radios do this. Now look at this. Coil and secondary just goes to ground. So that means if I measure the resistance from the grid here, if I measure it from here to ground or to the chassis, I'm going to get this big resistor here, 500 megohm. But if I measure it here, I should see pretty much a short circuit to the chassis. Just the resistance of this coil. It might be a few ohms in it. Let's do that test, because I suspect this is open. And I think somebody put a comment quite a few videos ago. I think they commented about this coil potentially being open. At that point, I should have open coil. Oh, maybe this one. So how could I put my signal tracer here and hear a strong signal? Well, again, the signal tracer is a radio. I can't really tell for sure just how sensitive I had it. Probably quite sensitive. And I'm basically touching it to a wire that travels through a capacitor to some amount of wire here, grounded or not, that's then close to this bundle, which has got the signal in it. I think I could be receiving it with a signal tracer, thinking it sounds solid and clear here, when in fact it's incredibly weak in terms of what this tube is really looking for. Why no detection occurring at all? Why no audio output? Depends on the style of detector they've decided to try to utilize here. I suspect this is a large signal detector. They're expecting a large signal here. Some volts of signal. Enough to push this grid positive on the positive side of the signal coming in. And they're looking for that. That positivity causes a current flow and a charge on the grid, and you end up biasing it appropriately. The bias on here I measured at 0.6 volts, maybe slightly lower, maybe 0.4 without the meter connected. It's hard to say. Even with no signal applied to the grid will establish a slight negative bias, half a volt or somewhere in that range, just like we saw with my meter. But it could be this is really intended to be biased much higher because of a higher signal that can't get there. Okay, so I've explained exactly what I think might have happened. It's going to be real simple to find out if I'm wrong. Let's see, I've been wrong every other time. Okay. expect a short circuit or nearly so. Okay. It's a big moment here. This could be the revealer. Okay, so this leads on the chassis. This one's going here. Expect that meter to go to 0. Okay, so my theory just went down the drain. That looks like 32 ohms. So the primary side does appear to be okay. Just for fun, we should get 500,000 on this test. There we go. 600,000. So that's the resistance of this plus the resistance in there. Okay. Well, okay, that was a that didn't last long. Why don't we try the primary side of this? Excuse me. So one lead coming here, and the other lead stay with me, meter. The other lead. Something odd about that. Something odd about this. Can't really. So this wire and this wire should be the same wire, the same lead. 0. Wait a minute, isn't this? Okay. This point here is grounded via this wire. Oh, this wire goes through there. Okay, hold on. So I think I glanced at this earlier. Wire not soldered properly here. Just here, take this out. Something not making sense here. Something is not making sense. It's making such little sense I can't even talk about it right now. $3.5K. As I look in the camera, when I glance at this, I see a wire going like that. But that's not what's happening. That's what's happening. Why is this so loose? I gotta think about this. Who'd do this? Put this in with a screw here. It doesn't fit. Well, why would somebody do that? And why would they leave it? Now this did look resoldered. Again, I'm not sure about any of these other connections. This one does not look resoldered, but it could be. Somebody replaced this, put it in the radio, turned the radio on. The radio didn't work. They threw up their hands and said, "I've had it with this," and walked away. They left this never properly connected and left the radio not working. But the radio did work. It worked quite well until I came along. For reasons I can't even explain, other than some cockamamie theory I have about the radio signal somehow getting past all this trouble and making it there. Cockamamie. Again. Just looking for something that will not make sense. This wire connection to this coil does not make sense. This leg here, you know what, I may have a real big mistake here. I probably do have a really big mistake. To recap, so this, that's recapacitor. This capacitor here has 3 different capacitors in it. Here they are, 1 connection, 2 connections, and the third one down here. 2 of these are on the heater legs of the 26 tubes. They happen to be positioned here where they can intercept the wires going to the heater. This other one is doing something quite different. It's on a plate circuit. It's here because this is here. The actual circuit is over here somewhere back at the other part of the radio. There should be a wire kind of running from the end of this capacitor all the way over to some other spot in the radio. That's not what I see. I see a wire going to this, which doesn't make sense. And I see this wire just coming to this terminal. So I have the feeling this guy is on one of the filaments, and over here is the line that I thought I was hooking up to. Okay, let's correct it. This is a filament, this is a filament. Okay, Jim, they're lining up with the holes. These are 2 connections to a coil up above. I forgot. There's a coil up above here. So this capacitor is hooked up to the coil up above. The other side of the coil up above here is heading for, it's coming from this tube. So here's the output from this tube. Over here, coming along this wire, going under the coil and reaching this transformer. This would be the primary of the feed to this tube. So the other side of this primary coil is connected to ground through this capacitor. It's also supposed to carry on. Carry on. I can't remember now. No, we've got to take a look at the schematic. We must look at the schematic for where this guy really is and what have I done here. Good question. I'm going to set it up so we can get both on the screen at the same time. I think it's going to help. Okay, let's see how well this works. I'll zoom in on the area we're interested in here. Make it a little easier to see. Okay, here we go. So, take a look at this coil. It's just supposed to go one leg up here and the other leg just to ground. You know what? There's another diagram here we can look at. It would be this one here. Oh, so here, look at this. It actually show you very clearly which wire should be going where. Look how they show them. And they even have colors: green, white, and yellow. So, okay, one at a time. I'll start with the green wire. A little pointer here. Okay, we'll pretend this is green. There it is, coming out and going right where it said it was going here. The other wire, so you can see how easy it would be to get this mixed up, eh? So look, there's two wires coming out here and two wires coming out here. So the two wires coming out here, one goes where I showed it. The other one should work its way to here, the plate connection on this tube, which it does. How's that? How's that match up with the schematic? I thought it showed a coil on the I thought it showed a coil going to ground. This goes to the plate. Okay, let's just do the other two. There's room for more confusion here. Let's go for it. The other two, one goes to ground, so that's this one here. The other one goes to this capacitor. The other one does go to the capacitor, doesn't it? And it connects. Oh my gosh, let's get a closer look at that thing there. Okay, that's about as close as we're going to get. Comes from here. Center pin. One wire goes back to the, what I think is a primary coil up above, some kind of coil. Okay, let's see if we can spot the one going back. So the wire comes over. One wire goes back. Yeah, right, just as shown. And the other wire goes on its way. On its way where? There's no wire going on its way here. Oh, I got this so jammed together. Hey, look. Way under there. There is a wire. There's a wire going into the bundle. So there's a wire going on its way. These two guys connect filament. Okay. So this is correct. I still have this large capacitor. Why does it appear to be on this coil? This capacitor is supposed to be working way back in the radio somewhere. But that is how it's shown connected. You can see this bundle of wires here heading to that terminal, and when you look on the diagram here, you see a couple of wires coming off this terminal. It just all looks normal. In terms of matching the picture there. Where's this capacitor really supposed to be? We can go back down to the schematic. So this is the capacitor that I'm questioning. It's actually hooked up to this line here. It's shown in this position, but it could be shown anywhere on this line, including right off the I don't know what they call it, the non-plate side of this primary coil. The non-plate side. What is going on here? What is going on? So this, I'm completely combobulated here. So these coils, 1, 2, 3, 4 of them. So these are the 4 things that are in the cans at the top. This one. So why? Oh, I'm confused. I think I'm looking at this tube when I'm looking at this tube on the radio. Oh, it definitely is confusing. Okay, that maybe make a little more sense. So I'm looking at this tube, and the capacitor is tied to the cathode. There is no cathode to tie it to. What is it tied to? It's tied to something I think is ground. I took advantage of a ground terminal. A ground dead, yeah, that's the word. Ground dead terminal on this tube. One of the terminals on this tube is straight to ground. I don't think so. I've taken the grid terminal and used it as a ground terminal on that tube. I think maybe that's a big part of the problem here. I really booped up. It's a long ways to ground from here. Oh no, it isn't. No, it's right there. So that's what I've done. I've stuck my own meter here, made a measurement, and decided this terminal was a ground terminal by finding this ground and ignoring this little resistance. So I gotta switch that. That's probably what it is. I've probably just done something dumb like that. So I'll move the ground of that larger capacitor, which is actually in this position, this ground. So basically I have this. Let's think about, I have this side of this capacitor hooked up here. That's dumb. So I have a big capacitor between here. Well, that certainly is dumb. That's my dumb. That's the dumbness. Okay, I found the dumbness. Okay, let's fix it. Okay, how surprised can I be that the problem is my problem, not the radio's problem. I can't be too surprised. All this stuff started happening right after I changed these capacitors. And look, I cleverly corrected these. That was a waste of time. It's not that these were the wrong size. It's not that this is the wrong size. It's in the wrong position. So we need to flip this off of here. What a dumb move on my part. Dumb. It's just dumb. That's the only way to describe it. Okay, let us bring up the soldering iron here. Now, where is a real ground going to be? Way back over here. That's why I went there. This is a ground terminal. It's grounded via this kind of grounded by this wire, which comes to a terminal here, which then goes to the ground terminal way over here. So this is a possible place to ground to. The other one's a little bit out of reach. I think this one's easier to get to. I just release it from here and extend it over with a little piece of extension wire. Okay, that's what I'm going to do. And the radio's going to come to life. You watch. Okay, So you can see where I've extended it to this ground terminal. It is a ground terminal. I see the ground terminal. Well, you know, dumb mistake? Yeah, yes and no. In the course of doing these kinds of things, working on radios I'm not that familiar with, going off in some tangent, even if it's completely wrong, still forces you through parts of the radio in detail. It forces me anyway. Makes me think much harder about everything as I get more and more intense and focus down onto a certain element, even if the problem is not there. It just makes me drag my head through the radio quite thoroughly. So that's why I'm quite comfortable with a mistake like this, and the results of it. I don't sit here and tell myself I just wasted 2.5 hours. No, I gotta put a tube in there. Pretty sure that's gonna help. Okay, now we're ready to operate this guy for the first time in a while successfully. So it sounds to me like I better be keep the volume low on the start. Volume's about, say, 20% up. That's not very high. Still have the loop antenna connected. Are we ready to go? I made a minor change here. Still have the alternate capacitor resistor good leak combination there. Okay, normal dim light operation. Now let's just see how wrong I am about things. She's gonna blow. Up with the volume. So I'm not hearing much yet. Oh. Oh. Again, I've got that tune it one way, get a certain signal strength, tune it the other way, get a much higher signal strength. Even a distortion. Okay, so that horror story is over. You know, a lot of these horror stories do end with me finding out I did something wrong. I have to admit to it. I must admit to it. So, my grand experiment to find out if you can use electrolytic microfarad, small microfarad capacitors in here, experiment got waylaid. Unfortunately, I still don't know the answer to that question, but I think these capacitors would work fine in this radio. But we won't know now, considering what I've done. So where are we at now? Now we're at the point where we should listen to the radio carefully, and then it's alignment time, and I believe the alignment is basically a two-stage thing. First stage is to set the feedback amount, the regeneration amount. That requires a specially outfitted vacuum tube and some special process, if you like, to achieve that. And then when that's called neutralization. Once that's done, then I believe there's an alignment, kind of a typical alignment, where you're just tuning each of the 4 stages to be in line, so they're all tuning the same frequency at the same time. So what have we noticed so far? So far, sound can be good. Seems like when I get the radio tuned up to deliver a powerful signal out of it, somewhere along the line, somebody is generating distortion. So let's hear that again. Like that. And I come back when I'm tuning it this way. It only gets so loud when I tune the other way.
Load management, and we're talking about somebody who logs a lot of minutes. Listening warriors now.
What are they talking about? Guess what? Basketball.
Hamstring injury that has some. He's questionable. But basically, we saw how that played into the Raptors' hands. Right? The Raptors essentially ran a.
This is a good job for a signal tracer.
Focusing on Steph and letting the other Warriors beat them, which you can do. Think without Klay Thompson.
So what I'm thinking is, with the speaker hooked up, it's a little difficult to do signal tracing because I got the speaker blaring away on a signal along with my signal tracer. Maybe there's a way I can set this up so I don't have to listen to the speaker. I could unplug the speaker. I don't want to do anything like that. If you send a signal in through the terminals, the first thing it does is it encounters this variable resistor volume control. And get on the other side of that variable resistor volume control, just sitting over here. That's not going to work well either. So I was going to keep the radio turned down so the antenna signal can't make it in. Then I was going to inject a signal further in. But this has got a dual volume control system in it. Well, what I'll do is I'll play the radio. Turn it down. But just try to make my signal tracer speaker louder here. Now what I want to try to hear is hear the same distortion in the signal tracer. Yeah, I could turn this speaker face down. Oops. Okay, well that quieted it a little bit. Grab a signal tracer. We're on RF. We'll start right at the antenna. Just get this where you can see my hand on the volume control here. Attenuator, front end volume control, back end volume control. Put it that way. So this controls what's coming into the signal tracer, and this controls how much it's amplifying it. You could look at it that way.
And data rate supply, go to sportsnet.ca/590 for full details. I cannot wait to go on and see how people are spelling Ananobi.
First tube input. Is there nothing there? Really? Nothing there. There's something coming out of the speaker. What am I doing here? Output of the first tube. Ooh, son of a gun. Okay, so volume's up a little high. Let me get my hand on it. How is it? There we go. I can't hear nothing coming out of this tube. Yeah, it's coming out of the speaker. Okay, well, let's start at the speaker end and work our way back. Let's go that way. So starting right here, grid to the detector tube.
Warriors. From a coaching point of view, Klay Thompson. Klay Thompson.
Let's listen for that distortion now. First, radio on its own. This is an odd radio because turning up the volume turns up the signal coming through the all these tubes. Turning up the volume could introduce an opportunity for distortion that a regular radio wouldn't, because a regular radio is actually just turning up the amplifier over here. It's just so different from a regular radio. I got all kinds of regular radio ideas in my head that aren't valid with this one. Okay, so here.
Defense in the second half of that game. What do you think he's going to see in Game 3 on Wednesday in Oakland? Because the best case scenario for the Raptors here is...
So I turned it up to the point where I could hear distortion. Now this is in stereo. You're hearing it in stereo too, but I mean, how good is it? Sounded to me like both the speaker here and the speaker here were getting distorted at the same time. Distortion's occurring further back. So let's jump back to here.
So Ryan was best good against level teams, but those guys are not great three-point percentage shooters. So you take your chances with other players beating you, and I think that's the dilemma right now that Steve Stern has. Is Klay Thompson just
filling with my microphones there.
In Game 3 on Wednesday, and if Kevin Durant does
distortion.
Return, this will be earliest Game 4. Now having DeMarcus Cousins in the lineup.
Yeah, I couldn't hear the radio speaker, but certainly there's a little bit of distortion building up in that tracer. Let's go back another one. We're going to end up discovering that the weak tube here is leading to distortion. That's what I believe is going to happen. One of these tubes is fairly weak. Let's try here. Output of this tube. Wow, there's almost nothing there. How can it sound like that at this point and then sound clear again up here? Let's go on the input to this tube. Back to the antenna. These big chunks and sounds you hear are charges going on and off the probe. I'm touching different voltage level parts.
He can put the ball on the floor for one or two dribbles because he has to respect his jump shot on the perimeter, so he can pump fake, take two dribbles to create.
So I think it's pretty dead here because I've got the volume turned down. This is a real quandary. Let me turn it up.
Recall, he scored 60 points in 29 minutes.
Quandary is right.
On 11 dribbles. In the one game of dribbles,
They tune in a weaker station.
So that's the type of player he starts with treating him offensive players. So people always keep us
So go 590, 610. Turn it up. Here we are. Oh, wow. That tuning direction thing is really obvious now.
Here's a My Kids story. Toronto District School Board has announced today they're changing rules
Distortion.
around what students
Perfect.
can wear in the classroom. They say they are now free to wear hats, hoods, crop tops, and spaghetti straps. So this will take place this September 2019. It basically draws on what principles of equity, anti-oppression, anti-racism, non-discrimination, equitable and inclusive education. Are the principles this draws on, the board says on its website. We tried to get someone from the Toronto District School Board on the show to talk about it and the specifics, but
I'm laughing because I still have my signal tracer tuned to the other station.
they want to back off. Basically what they did is they consulted a whole bunch of people, including teachers, parents, education workers, and to find out exactly if they should be more stronger dress code in the Toronto District School Board.
to get the team.
The fact that when there are rules enforced around certain clothing, like crop tops and spaghetti straps and hoodies,
It's really
but it
great.
unfairly discriminates against specific kinds of students. There's a student citing here in a Christie article, student Marley Vonich, who remembers one instance when a classmate of hers was sent to the office.
Well, that's pretty interesting. I can't pick it up with this. This radio, at this point, seems to be receiving better than this one. Incidentally, this radio uses the same technology approach, if you like, radio reception technology approach, as this radio. They're both what are called TRF, tuned radio frequency radios, which means they're tuning radio frequency throughout the radio, as opposed to a converting radio, a super heterodyne radio. So these are both the same. So the fact that this guy is picking up the station, this guy's not. That's hard to believe. It's really quite hard to believe. So I don't need the volume up here to hear this on the antenna. So let's try this again. First, what's on?
I have no style.
It's a woman screaming she has no style.
That's why he gets Oprah all the time.
There it is. Way better reception out of this. That's amazing. Okay, now trace that signal. Antenna. Start here.
Laptops? I mean, he's wearing that.
That
And say, let me just see how,
much lower.
far up you're going, or how.
Back. It's the output from this tube.
Appropriate or not. I just think he's wading into some
there, but it's
dangerous
lower.
territory, and I get.
Here. Bang.
I don't think you should be walking around.
Messy.
Okay, what I'm worried about here, I have to worry about what some creepy older person, thinks, or what some creepy fascinating guy,
Stunning to me. Okay, this one. Output of this. Oh. It's interesting. Turn this guy down here. Interesting to me. A strong signal at the antenna. First tube, second tube, you can hardly hear the signal. It's all lost in kind of noise in that. Somehow you take this noisy, crappy signal, you can move it through this radio, and by the time it gets here, it's cleaned up really pretty good. That's pretty surprising to me. I would think if it sounds like crap here, it's just going to sound like louder crap here, but that's not the case. Of course, each time the signal goes from one stage, this tube, this tube, this tube, or this tube, it's going through a tuned circuit, which is pushing away the unwanted signals that are just outside the range you're trying to tune to. There's a frequency response of my instrument here. I don't know what it is. It could be that this has got a really wide front end. So it could be this guy is actually quite narrow, and this guy is really wide. What's it eating? It's eating the signal and all the noise that's in here, whereas this radio is eating the signal and not much noise. That's my only explanation for why the signal tracer sounds so much worse than the radio itself. So what we should do, one last thing we should do, we should restore the original arrangement here. I put in a temporary grid leak system there. Just untangling some wires. So I should restore this and verify the radio works. I'm sure it will. Let's do that. My soldering iron is still, I can hear power off, wire off. I have some new soldering iron tips here. I haven't put them on yet. I'm still using the big wedge. What happened there? Did I bump the camera at some point? I want to just solder it back there. So my story about this coil is probably still valid. Somebody probably replaced this coil. Why didn't take the time to make it solid? I don't know. And it could be even Mr. R, who's watching me do this right now. Did you do this, Mr. R? So one of the hardest things to find in a radio is an error like the one I made, where the connections, maybe I'm going to leave this here. we might want it. Where the connections no longer match the schematic. So when you look at the schematic and try to rationalize what the radio is doing, you're not looking at what's really going on. And so it's just perpetually confusing. The other thing too, and am I the only one who does this? When you make a decision to do something, it's pretty tough to get you to go back and reconsider your earlier decision. That's a human trait I think we all have. Ready to go. Those are my excuses. And we should be hearing it, shouldn't we? Shouldn't I just leave it all tuned and ready to go? Anybody explain what's happened here? What happened here? I broke it again. Climbs up quite high. So the output I think is dropped. So I was reading up on grid leak biasing. It's for the umpteenth time in my life reading up on it. Every time I read up on it, it just gets more complicated. It's just a little capacitor and resistor used in a detector, as a detector with a detector tube or a triode. And it's a head splitter for me, understanding exactly what all's going on. So if you think it's simple, you probably haven't read enough about it. So I think what we'll do now, I think, is we'll turn our attention to the alignment process. First of all, the neutralization, and then after that, the actual tuning alignment. And then we can assess the radio for what it is at that point. We might decide to hop tubes around, try to improve it a bit. We might find one of these tubes is really not rowing enough with the rest. Maybe we need another tube. I don't think so though offhand. That's it for now. Great. Okay, so yes, I'm revealing I made a mistake and spent a couple hours finding it, but like I said before, that's okay. Learn to pile the stuff along the way. So thanks for watching, and I'll see you on the next video.